When we talk about generating word lists, there's a lot of different approaches to this, and what I'm going to do is just kind of give you a short survey of a few approaches, but there's no wrong way to generate a word list. A word list is just a collection of words. So however you get the job done, kudos. It's just these are some ways that you might think of, or you might use these in combination or use these as inspiration. So one of them is cool. Robin Wood goes by DigiNinja, and that's his site as well. He comes up with all kinds of neat tools, scripts, and other little gadgets that help out with all kinds of things in pen testing. He also put together the zonetransfer.me zone for you to practice zone transfers with. He's got all kinds of neat projects to help people learn about pen testing. One of the things he put together was cool, and what it does is it goes out to a URL that you specify, and it grabs all the words greater than 4 characters long. You can change that if you want to by setting the minimum word length to whatever you want to set it to. So how would you decide what to set the minimum word length to? Because that's you gotta pick a number, right? Password policy. So, barring that, keep learning about the system. It's pre-installed on Kali along with another tool, Fab. And Fab is similar to Cool, but also from Robin. And what Fab does is it essentially does the same thing with the metadata that's in documents. So it'll scrape through the document looking for words and make a word list out of the words in the document. So it looks at just looks at all the words in the document. You know, there are words in documents that you can't see if you display the document in the standard viewer. Like if you display a docx in the standard viewer Word, you don't see a lot of the information behind the scenes like the author who wrote the document. But Fab can get that information out. You can also use the program Strings that's built into all Linux standard program. Crunch will actually literally make up words, and that's its role. And the way it works is you tell it how the shortest word you want to make, and you tell it the longest word you want to make, and the character strings that you want to make the words from, and it'll just make all possibilities. These are not words in the sense that they're going to show up in a dictionary, you know, like an actual word you can use in a sentence. When I say word, I mean a series of characters, a string, so it's just going to generate all possibilities. It has a bunch of other options as well, and it's definitely worth looking at. It can do patterns, which is really cool. So like if you just want to say put a lowercase letter in this spot in the string, you can just put the @ symbol, and it takes that as A through Z. It doesn't need you to say A, B, C, you know, by hand. So it's got some shortcuts or macros built into it. Comma is uppercase, percent is numbers, and caret is symbols. And so with those basic 4 patterns, you can mimic the password policy that you run across pretty easily and generate a word list of all possible variations of that pattern. Obviously, for long patterns, this is not going to be too practical, but for short patterns, this is way better than trying to have John generate them itself on the fly if there's a whole lot of patterns. So it's a tool in the toolbox. When is it best to use this brute force style approach? When you can. Sometimes the password length gets too long and this type of brute force becomes impractical. But again, Crunch is just going to generate all possibilities of the patterns you specify. You don't have to list every possibility. You can tune it yourself. Here's some examples just to kind of illustrate the point. So if I wanted to generate all the letters that had a single character and then also pairs, I could do Crunch 1, 2, and it's going to generate A through Z, obviously, for the 1. And then for 2, it'll generate A, B, so on until it gets to ZZ. One of the things you can do is you can kind of tune it a little bit. So you can say, well, I don't want any duplicates of characters one after the other. So in that case, it would generate A to ZY, but it won't do ZZ because that would be a duplicate one character later. So it won't do AA and it won't do BB because those are two consecutive characters, and so on. Lots of different ways to specify how to generate the list with Crunch. And of course, once you get used to tuning it a little bit with its fairly straightforward syntax, it's really powerful because you can dial in the exact word list and generate it fairly quickly. If you're trying to make a lot of words, you got to be careful because it'll chew up the disk. So just kind of got to think through how many words you're going to generate before you do it. There's really a couple of different word lists you're going to need, and you should be adept at doing both. The dictionary attack we just kind of worked through. And probably a good way to do a dictionary is just get the words, because you're going to use them as is, right? We kind of said it was a little bit of a misnomer. It's really more of almost like a password list. Just get the list of words from whatever sources you need, shove them all into a big file, and then just unique them. So this sort-u will take in a word list that probably has all kinds of duplicates in it. It'll sort everything and get rid of the dupes. So what comes out the end is a sorted, unique word list. Very straightforward, and Linux is adept at doing this kind of work. Probably a way to do it in PowerShell too. So, hybrid, a little bit trickier. The point of using a dictionary is to use it as is. You can mangle it too if you want to, it's fine. You can use RockU and then use rules on it, not a problem. But when you're doing the hybrid attacks, normally what you're starting with is a pure dictionary. Lowercase, no dupes, no craziness in the file, because you're going to generate the craziness with your rules, right? So you don't want to have like, punctuation in there to start with, because it'll mess up the rule that you have that generates the punctuation, right? Because it'll throw it off. So it won't be the pattern that you think it's going to be. So you really want to kind of start with your raw words, and that's fine. You can get them from natural language dictionaries like the Spanish dictionary. Fine, great place to start. And you want to basically lowercase everything, and you can use this tr command to transform anything that's upper and back into lower. And of course we can pipe things, so we can do things like this where we also do a transform where we delete any characters that are not A through Z. So because you might get a word like password 1, and you don't really want the 1 on the end, because if you have a rule that adds a 1 on the end, it's going to say password 11, right? So you want your hybrid dictionaries to be more pure. You don't want to have those dangling characters on the beginnings or ends that are going to mess up your rule and mess up the intent that you have. And of course, the best word list, the one that works. It's usually highly situational, highly contextual, and it's based on knowledge of the system, generally speaking. You can take a word list that you have, for example, one you generated, or perhaps a word list that you already have that you really like, that has lots and lots of words in it. Get the password policy from the system. Run password inspector on the file. It'll filter out any of the words that are not possible for that password policy. Really good idea, because password cracking is all about time. And if you have any words in your dictionary that are not going to work, you're wasting time. Some of these passwords are pretty hard to crack, and depending on how much power you have to generate guesses with, it's going to take a while. And you want to try to eliminate as much of that as you can. This can be pretty severe. We had one engagement where we were trying to crack some fairly difficult hashes. They were salted. The hashing algorithm was SHA-256. It's a pretty tough algorithm to generate from. And it wasn't going very fast. And when we did the initial test run, just to kind of see where we were at, it was going to take us 30 days to get through the dictionary. So we used some techniques like Password Inspector to filter down what's really possible, and it got it down to like overnight. So next day you come in and it made it through the whole list. So it can make a huge difference. This can be, take weeks off of your password cracking attempt. Another reason I like Password Inspector is it's easy to use. Password Inspector actually comes with another tool in Kali Linux called Hydra. So if you're looking for the Password Inspector download because maybe you don't have it for whatever reason, you actually would go to the Hydra website and download the Hydra package, and it's one of the programs that comes with that suite of tools. So, but you just pass it the input file and the output file, and then the policy. And the way you specify the policy is you say the password has to be at least this long, it can't be any longer than this, and here's the characters that I'm allowed to use. And really quickly, it's lowercase, uppercase, and symbol are L, U, and S. N is for numbers, and then the difference between the S and the P is the P is for printable characters, characters you can see. So generally speaking, when you're making a password policy with Password Inspector, what you're really going to use is L, U, and P, and you're going to put it in the order that makes sense. You probably don't really want to use the S. I know it says special characters, but that includes non-printable characters. Unless you're going up against somebody that has a crazy password, it's a little bit of a reach. You probably would come back later and make a second dictionary if once you got through the first dictionary, that's a little bit more likely to work. Okay. So, as an example, if I were to put some words into a file and then run Password Inspector on them, it'll trim it up. Alrighty, so I'm echoing password and capital password and password 1 and capital password 1 into temp password. The very first echo I did, I used that regular redirection we've been using all morning. When I did the second one, to avoid overwriting what I'd already written in there, I added two greater than symbols, which means append to the file, don't blow out what's already in the file. That's why there's 2 in all the subsequent echoes after the first one. It's because I didn't want to overwrite what was in there. I just wanted to add words. The cat command can print what's in a file. So if I print, after I do the 4 echoes, if I print, I have the 4 words in the file. Okay, so the command is a bit daunting, so I'm going to copy it. Okay, we have to have between 8 and 12. So let's break it down. Input file is temp password for obvious reasons. That's the password file we created. I'm going to output to candidates. I need passwords that are at least 8 characters long, but at most 12 characters long. Letters, uppers, numbers, and I went ahead and went crazy and went symbols. And then that's going to end up being in candidates in the end. So you just do that and then cat out candidates. Oops, sorry, it's not just candidates, it's temp candidates. And the only password that survived the password inspection was just password 1. Let's look at the other passwords and see if we can reason why that was. So this was 8 characters long, which is okay, but it doesn't have an upper in it, and it doesn't have a number. And this one has the upper but no number. This one has the number but no upper. And this is the only one that had at least upper and a lower and a number. And it could have had an upper and a lower and a symbol, or a number and a symbol and an upper, or whatever. The way that you say like 3 out of 4 is with the combinations, the -C. So here I said -C. I provided 4 formats, and I specified that you have to pick at least 3 of the 4 specified, and password 1 has 3 out of 4. Little bit learning curve just to get used to the syntax, but once you do, very easy to specify password policies.
C2, it would have only eliminated the first password.
Right, yeah. So should have eliminated the first one. Should be 3. Whoops. I keep forgetting to put the temp on there. So it would eliminate. Yeah, would eliminate the first 3. Pretty straightforward once you get used to the little quirky syntax. Which actually, once you get used to using Linux, you'll actually love this quirky syntax. It's fantastic. So it makes things really easy to automate. So to do the lab, we're going to put some words into a file. Technically, when you're creating a file, you can technically say echo password, for example, and then double greater than symbol right off the bat, and it'll just append to the existing file if it's there, or it'll start a new file if it's not there. The reason I'm being a little picky and I'm starting off with a single redirection symbol is if the file is already there, because I've already been doing the lab before, I want to overwrite whatever's there and start fresh. Okay. Then in the very second line, that's when I start using the double redirection to append to the file that I just created starting fresh. So hopefully that makes sense why I did it exactly the way I did it and not the other optional ways to do it.
Purposely make line 2 and 3 identical, or?
Yes, I purposely made those identical on purpose. There's a method to the madness.
Okay.
The line 2 is the word password uppercase P, and line 3 is just repeat line 2, which means you could just arrow up and hit enter again. Absolutely. Good point. Thanks for pointing that out. And then you're going to run password inspector on it. The reason that I intentionally put 2 uppercase password in there on purpose is that when you get to the next part of the lab and you do the sort -u, I want you to notice that it's going to unique the lines, and it'll have the password uppercase password only one time. And then finally, in the last part of the lab, we're going to transform our dictionary file, which has passwords as is, and we're going to transform it into a pure word list suitable for using rules on. And that'll be the third step. So what I'll do is I'll leave these up here for a minute and then give you a minute to try this out, and then I'll run through the lab.
If you leave off the Steve 3 and only list LUN, is it going to just take all of it? They're going to assume C3? Or
Yeah, by default,
just takes whatever?
if you don't specify like 3 out of 4 or 2 out of 3 or whatever, if you don't say anything, it's just going to go all out of all. Yeah. Chances are, for most password policies, you're probably going to need that C switch to tell it how many out of how many, because most password policies are not absolute. Most of them allow you some freedom to choose the kind of symbols.
Is there a space after password -o?
Oh, yes, yes. Yeah, there's spaces basically between everything. Yep. He's asking right here in this line here, he's asking if there's a space after the O. There is a space after the O right here between these two. Yeah, -O is output, and then the space, and then the name of the file that you want to output to. And there's nothing special about these file names. I'm making them up. The reason I like to put things into the temp is because Linux automatically deletes the temp directory when you log out, so it cleans up after yourself. If you have it set to clean up. Okay, so if you're doing just fine, just keep on going. I'm going to do a walkthrough. So I'm going to recreate the temp password file. I'm going to add an extra step into here, and I'm just going to cat out the contents of the temp password file to make sure that it did what I expected it to, and to make sure that the word password is in there twice with a capital P. Then we'll recreate the password inspector call that we did earlier. And we're going to do password inspector with 3 out of 1, 2, 3, 4. So it's 3 out of 4, minimum 8, maximum 12. And I'm going to cat out temp candidates, and I'm going to get the only survivor was capital P password 1. That was the only thing that had 3 out of 4 characters in it. So that would be our new dictionary in that case. Next, I'm going to simulate transforming our password list into a dictionary suitable to use with John. Again, the reason that the password list is not suitable to use with John as is in the raw state is because it has duplicates in it, and we don't want duplicates. So by using sort-u for unique on the file and then redirecting the output into temp list, I now have temp list that is still a dictionary. It's still having the words as is, but there's no duplicates. This is suitable for use. Let's say that I was going to do a hybrid attack because I wrote some rules, but I didn't want the little vagaries of the words in the dictionary to mess with my rules and mess up my intent. I could transform the password file by first transforming it, whoops, sorry about that, with uppercase into lowercase. I can pipe that into another transform back to back, and I want to delete the complement, DC, I want to delete the complement of A-Z, meaning if it's not a lowercase a through lowercase z, I don't want it in my list. Now remember, in the first step, you might think, well, that's going to knock the capital P right off the front of that word, but it won't, because the first step was to lowercase the capital P's. So the letter P will survive the second part. So, oops, and I did make one mistake. I forgot to preserve the line feeds. So, my bad. I got to fix that real quick. So that's not going to do it all. Yeah, that's what I was trying to remember how to do that. I don't think that works, though, for some reason. Oh, yeah, that's right. You did have to add the new line character into the... It's a little confusing, right? So D means delete, basically, or drop or delete, however you want to say it. But C is complement, so it inverts the deletion, so it means delete what isn't in what I'm about to tell you. This little /n is a little confusing if you're new to Linux. It's an escape character that means the line feed, the inner key. It means the inner key, basically. So now there is one problem with my temp list. Does anybody notice what it is? It's not suitable for use with John in the hybrid mode yet. Yeah, it needs to be sort unique, right? So pipe. And that'll add the sort unique. So hopefully one of the things you're picking up on today, but besides the information about passwords, is kind of seeing how these little commands in Linux can be chained together to do tricks without, having to manually edit files. When we have just 4 words in a file or 5 words in a file, sure, you could do gedit, you could do all this by hand pretty easily, probably easier than what we're doing here actually. But when you have 14 million words in a file, you might want to use the automation. So, okay, I'm going to change the top here to the final command that we came up with.
Hello everyone and welcome to part 11 of my Learn Ethical Hacking. So in this part we're going to create a backdoor. And a backdoor is essentially an evil program that when the person runs it on their computer it will give you access, hence the name backdoor, and this access will allow you to control their computer. You can upload things, you can execute, you basically have full control of their computer. Now there's a lot more to that. It seems very simple, but there's a lot more that goes on to actually achieve that. But in this video we're just going to generate the actual .exe or the application that will allow this connection between you and a victim computer. To actually create the backdoor in Kali Linux we need a few things. So to download this, all the codes or commands I should say are in the description, so you can copy it line by line if you want. It's to save you typing all this out. It's line by line, so don't copy and paste all of it in one go. You just need to open the terminal and get the first line, and this first line is installing git. So it's apt get, so hyphen between apt and get, then space -y install git, and this will install git so you can clone repositories, you can upload to git, etc. Once you click enter, I'm not going to click enter because I've already installed it, and like I said in this previous video, and in case you're confused why I'm saying that, is because this is a re-upload. So if you've already watched this video, then, or you've already watched the original within the 24 hours it was uploaded, I've decided to make this video again and re-upload it. The previous or the original video is no longer available, so if you're only just on part 11 then this video will be good for you. If you've already watched part 11 then you can still watch this. There's a little bit more information that I wanted to actually get into this video than I did in the original. Anyway, once you click enter, this installation should only take a few seconds. It did for me. And once it's complete, you can actually clone the repository. And this repository is this one here. This GitHub repository includes Veil. And Veil is what we're going to be using to actually create the backdoor. Veil is just a Python script that allows you to create backdoors using payloads, etc. You type that in like I have, copy and paste it. Once you click enter, it should start cloning it, and cloning is essentially just copying it from like the GitHub website to your local drive. So if I go to places and click home, then I go to, in fact it's straight in the home, so it's here, and it should be a Veil folder for you in your home place. If I double click on this, it's got all the files from the repository. Next, what we need to do is we need to actually go to this directory, but in the terminal, because we need to run the setup folder. So if we just get rid of all that now, if we type cd veil, click enter, as you can see the terminal will automatically go inside of this directory. So if we type ls, as you can see this corresponds to the file manager. Everything that's named here is essentially inside here, inside this folder. So now we know we're in the correct directory. Then we need to go inside the setup folder. So to do so, you type cd and then setup, click enter, and now we're inside the setup folder, which is this one here. So essentially we're inside this. Now to actually run the setup, and this setup is an installation of Veil. There are 3 installation wizards. These installation wizards are all interpreters, so you'll install Wine, you'll install Python and Ruby. It's all required for you to actually run Veil, because there's loads of different payloads within this Veil, which you'll see later on in this video. So we're inside setup. Now what you want to do is you want to type sudo /setup.sh. Like I said, all of this will be in the description. So inside this leaf pad here, this will be in the description, so you can just copy it line by line. Once you've done sudo/setup.sh, then you can do space-c. Once you click enter, it'll start the installation process, and this is the long installation process. So give it 5 or 10 minutes. You will need to watch the installation though, because the installation wizards will pop up and they require you to click next. Tick boxes, don't worry about, just don't tick any additional boxes that appear in the installation wizards. Just keep clicking next on all of them. Then it should take you to near the end of the installation. If errors do appear within the terminal, ignore them, because it still works. So don't worry about any errors that actually show up within the terminal. If you're stuck with this installation process or something unexpected does happen, then just leave it in the comments and I'll be happy to help. But you should be fine. Once you go through the installation process, they will appear like an actual installation wizard. So the whole screen will go blue, I think, and then there'll be like a little grey box that says click next, and then it'll just do the installation with the loading bar. So once that's done, you've installed it correctly, you've got Veil now, and all we need to do is actually execute the Veil script. And to do so, we need to run this veil.py. So I'm going to go back into the Veil folder. I'm going to do type clear, sorry. So it clears the terminal. Now we've got a fresh terminal. To run this py file, we need to do /veil.py. Veil.py, click enter, and then it opens Veil. So now, as you can see here, it says Veil version 3.1.4, and we've got main menu, then it says here 2 tools loaded, and we've got available commands. We've got exit, info, list, update, and use. We need to list the available tools, so you type list. These are 2 different tools, so evasion and ordnance. We want to use we want to use evasion. So type use 1, click enter. Don't just type 1, you've got to type use 1, because this is a command. Now we're using Veil. So as you can see up here, it says Veil evasion menu. We've got 41 payloads loaded, and then we've got additional commands, so which I'll talk through later on. We need to type list again because we want information on a specific payload we want to use. So type list, and these are the 41 payloads. We're interested in 9 or 10. It doesn't really matter which one you use here. The purposes of this course, I'm going to be using 9. I'm going to use reverse. In fact, no, I'll use HTTPS. It's just, there's not much difference between them. It's just that HTTPS, I don't know what it is. It's just preference, so I'm going to use 10. The corresponding number is what the command we need to use. So the HTTPS one is 10. So if we go down here again, just scroll down and type use 10. Then we're using CS interpreter reverse HTTPS because that's the one we selected with using 10. Then you can see additional required options. We've got compile to .exe and the value is Y. We want it to compile to an executable because when you send that to a Windows machine, then it will run because it's like an application, it's just a .exe. And throughout this course I will be talking to you about binding it to like JPEGs, making it, in fact Veil evasion does make it undetectable by antiviruses, and there's important information that I've got to let you know at the end of this video, so stick around for that because it's very, very important that you listen. But the most important part of this, not to make the video extremely long, is lhost and lport and sleep. They're the 3 main common ones. There's also processors, but as you can see here, these are optional, so they're not actually required. The main 2 of these two for it to actually work. So we need to set the lhost, and what the lhost is your IP address of the Kali machine in this case. So it's the IP address of that, and to find that, all you need to do is you need to open a new terminal. I'm going to split this horizontally. Now, you may be wondering what terminal I'm using here because it might look a little bit different with this red line. I'm using Terminator. So if you go to Google, you can search how to install Terminator in Kali Linux. You can install it. It's not required. It just has additional features. It's exactly the same as the terminal. So I'm going to clear this and then type ifconfig. this ifconfig will bring up all the connections, like the Wi-Fi connections or wire connections. I'm using ETH0. So to find the IP, it's inet, which is this. So this is the IP address of my Kali machine. So I'm just going to copy this and then type set lhost and then paste the IP address. Click enter. That sets the lhost of the backdoor. Because we're using reverse, it needs to know where to go back to, if that makes sense. So when you send this application somewhere, it's going to have to listen for a connection, or your computer is going to listen for a connection from someone else's computer. So it needs to know where to send the connection back, if that makes sense, from the victim's computer to yours. Your computer is going to be listening for a connection, and then their computer, the victim one, is going to send it's going to have to know where to send the connection back to, which is your computer, which is also listening for a connection, if that makes sense. So that's why you set the IP address of the L host to your IP address. We've got the L port. You can change this if you want to. By default, Veil Evasion has it at 8081. You can have 8080. The reverse HTTP uses the 8080 as well. You can use 80. You can use 4444, so 4 fours. I think there's other ports as well that are good to use, but I recommend 80, 80, 80, or 80, 81. So you can leave this as default. The L host has been set. As you can see up here, it's blank. Don't worry about that. It doesn't automatically refresh, but it's definitely been set because there's no errors. We can add some processes if you want to make it look like an application that's actually running. So it uses, processes. Sleep. You can make it sleep for a certain amount of time before the payload is executed on their computer. You send your backdoor to someone, and they double click on this dodgy application, then it will sleep for 5 seconds before it actually executes the bad code, if that makes sense. It's like a bomb, for example. So yeah, you could set that to 10 seconds. It doesn't really matter. It's optional. I'm not going to set it to anything. So as soon as they double click on it, it will access the connection, or it will open the connection, and then you'll have access to their computer. You can leave everything else. You don't have to mess with anything else. So that's it. We've set the L host. We haven't set any of the optional ones because it's not really required, hence why it's optional. So lastly, all we need to do is actually generate. So you type generate because we want to generate it, which is this one here, to generate the payload. You type enter or press enter. Then we need a name for the payload, so I'm going to type backdoor. Now, in the original upload of this, I called it backdoor.exe, and then when it created it, it created backdoor.exe.exe, and it looked a bit retarded, so just type backdoor. Do not add the .exe extension to this. So I'm just going to click enter, and it's not a good idea to call it backdoor because people will not open it, but that will be talked about later on in the course. But there are ways of defending against this, which is quite simple, really. So we've executed it, and we've created a payload that's in an executable form. As you can see here, this is the most important line. So to actually see this in its real form inside the file manager, go down to this second terminal. I'm just going to type clear to get rid of all that. We can do a command that will open the directory. So you type xdg -open. I'll just zoom in so you can see this. So it's xdg -open, and then we can copy the executable line, which is this one because we want to locate the executable, up to the compiled, because we don't actually open the backdoor.exe because it's just pointless. If you send this to someone right now and they double click on it, nothing will happen because we need to listen for the connection, and that will be in part 12. This is only generating it. So we do xdg open and then click enter. It will open the file manager straight to this directory, and as you can see here is the backdoor, literally called backdoor.exe. So this backdoor is our weapon essentially, and that's it. So you just generated your backdoor. It's working fine. We're using the right ports. We know how to generate one now, and this is with Veil 3, so it's not with the old version. All the things will be in the description as always. If this video did help, please leave a like, comments. If you're stuck with anything, I'll be happy to help. Subscribe for future content, and I will see you in the next video.